Hello again. As promised, I had gotten some questions from some of you asking if I would go over more of the ratio. Sorry, it keeps doing that sometimes. Give me a second. Asking if I would go over more of the ratio word problems. So I've shown you what slides that these come from off of your SI session today. So if you want to find them, you're welcome to follow along. Um, Let me see if I can get this working again. Give me 1 second. Okay. That is not what I want. Hang on. There we go. Okay. So this is from slide 24 of your session today, and I'm going to go through, I think, 2 through 5. 2, 3, 4, 5. Yes. And then back on slide 30, where I was already doing ones that your SI leader had asked me to go over, there was also another word problem one, so I went ahead and picked it too. So that covers almost all of them. But if I missed going over something from today's SI that would be helpful to you, please email me and just give me a slide number. I'll go ahead and repost that PowerPoint so you have it and you can reference the slide numbers. Okay, again, just as in the first video that I did, I tend to do these questions from an algebraic approach and a systems of equations approach, so you will continue to see that. Also in the word problem, if it is possible, I pick my letters to actually kind of stand for what they were in the problem, so that can kind of help me reference what I'm doing. So reading through this problem, you're throwing a party and you need 5 liters of Coke for every 12 guests. 5 liters per every 12 guests. So then they tell you have 36 guests. How many liters of Coke do you need? So that would equal X liters that I want to find per 36 guests. And then I like to include the units when I'm setting things up so that I make sure I'm consistent. If I put liters on the top for the first ratio, then I have to put liters on the top for the second ratio, which I've done. But now I'm going to simplify those units out of there so I know what I'm solving mathematically. So I want to know when 5/12 equals X over 36. If you keep all the labels in there, this XL part up here can tend to get confusing, remembering that the L is just the liters, not what I'm actually trying to solve for. The X is what I'm trying to solve for. So I like to use my units in my setup, and then when I'm actually solving, I take that out and just pick out the math that I have to solve. You could cross multiply to solve this one because you have one equation on the left and one equation on the right and they are set equal to each other. But if it's hard to remember when you can and when you can't, a strategy that works anytime you have fractions in an equation is to multiply by the least common denominator. Least common denominator here would be 36. So multiply both sides by 36. The 36's just cancel out exactly on the right side. But on the left side, 36 divided by 12 is 3. So I'm left with 3 times 5 equals X. So 15 equals X. Well, what does that actually mean? That means that I needed 15 liters of Coke per 36 guests. Go up and read if that answers your question. Yeah, if you have 36 guests, how many liters of Coke do you need? Yep, that figures it out for me. I need 15 liters. Done. Okay, next one, still slide 24, question number 2. This is one on the CE webinar videos that I've also broken into a category on pictorial representations. I think it's helpful to draw pictures. So they tell us we have a rectangular field that has an area of 300 square meters. That means length times width. This area inside here is 300 square meters. Then they tell me that the perimeter around the outside is 80 meters. So if I draw that out in my head so I can actually think about it rather than just trying to memorize everything, notice I'm going around all 4 sides. I'm going around the length twice and I'm going around the width twice. And that 2L plus 2W is equal to 80 meters. Okay? And then I know that L times W, because that's how we find area, is equal to 300 meters squared. Well, this is a system of equations. You have two equations and two letters, and so you can solve by substitution or you could solve by elimination. This LW here does not lend itself to elimination because you don't see an LW term up in the beginning. So what I'm going to do is I think it's easier to not deal with fractions. That means I'm going to hone in on this first equation, and first just go ahead and divide everything by 2. So I'm going to get that L plus W is equal to 40. Just like in the last problem, units are helpful to get you started, to realize that I need to add up all my dimensions to keep a dimension of meters, versus I need to multiply my dimensions to keep a unit of meters squared. Units are helpful in your setup, but units kind of clutter the process when you're solving, and so I'm going to drop the 80 meters part and just look at the 80, but again, I chopped everything in half from that first equation. So L plus W is 40. It is always easier to solve for a variable, in the equation where the variables are added. So I'm going to do that. It doesn't matter whether you solve for L or W. I'm just going to solve, oops, sorry, switch my colors. I'm just going to solve for L. So L is equal to 40 minus W. Well, now I'm going to take that and I'm going to substitute it in to this purple equation wherever I see an L. Instead of an L, I'm going to write 40 minus W then. So in my second equation, instead of L times W equals 300, again, instead of that L, I'm going to write 40 minus W times W equals 300. Now I have an equation that's in one letter, so I'm able to solve it. So then I go ahead and distribute. Oops, sorry, my board's being a little weird. So I get, I'm going to switch colors, 40 W minus W squared is equal to 300. This is a quadratic. Your strategies for solving quadratic equations, it's easiest if you make them equal 0 first so that hopefully you can factor. I like to get my x squared, or in this case w squared, term to where it's positive. So I'm going to do 0 equals and add the w squared to the other side so it's positive. W squared, I would then subtract 40w, and then I already had a positive 300 over here. And so now I need factors of 300. So I need numbers that multiply to 300 that add up to negative 40. So let me see. Why don't we start with easy things? So the 300, I could look at 100 times 3, but 103 are 97 units apart from each other, not 40 units apart. But another easy multiple for the 300 is, what if I did 30 and 10? And 30 and 10 does get me to 40 if I use negatives on both. Well, negatives on both is actually good because a negative times a negative is a positive 300, and then a negative minus a negative stays negative, so negative 30 minus 10 is negative 40. So this factors to be parentheses w minus 30, new parentheses w minus 10. I set each of those factors equal to 0, so if w minus 30 is 0, w is 30. If w minus 10 is 0, w is 10. Okay, going back to the original equation, or original question, sorry. They want us to find the ratio of length to width, so I also need to find the lengths. Remember back up here, length was 40 minus w. So length equals 40 minus the w that I came up with of 30. So length is 10. That's one pair. That length is 10 and width is 30. Another pair. Length is 40 minus w. In this case, I came up with a w of 10. So that means my length is 30. Okay, so another pair is that my width is 10 and my length is 30. And this might seem like we have two different answers. We don't. It just means that in my original rectangle that I drew, which we color coded it two different ways, so let me just draw one that is a totally different color. I could call this L and this W if I wanted to, and that would be this representation where L is 30 and W is 10. Or I could just as easily think about it this way, where then you have L is 10 and W is 30. It's just a matter of how you rotate it and what you call the longer side. That doesn't matter. Okay? All right. However, they want to know the ratio of length to width. Now, looking in your SI solution, she had in there that length needed to be greater than width. It doesn't really have to be. I do think to be able to answer this question, because my final answer is supposed to be what is the ratio of length to width. So L to W, or L to W that way, however you want to write your ratio. We would have two different ones. We would have one that was 10 to 30, or we would have one that was 30 to 10. And in a multiple choice, they're not going to have you do that. So they could give you a picture to start with and tell you that it is drawn to scale and labeled already L and W, and then you could pick out which one was bigger. Or they could tell you to assume that the length is the larger quantity, but just in general, you can't assume that length is bigger than width. That's not always the case. Okay? I like to think about my ratios in fraction form just because it reminds me to reduce. You're not going to see a ratio of 10 to 30 or 30 to 10. You're going to see the cleaned up version, and you get the cleaned up version by doing 10 over 30 is 1/3, or 30 over 10 is 3. Okay? So the ratio they're going to give you for this one is 1 to 3, and the ratio they're going to give you for this one is 3 to 1. If we assume that L is greater than W, then you would pick 3 to 1. L greater than W. If we don't make that assumption and we don't know, then we could just as easily have one where L is less than W. Okay? So either of these technically works. For multiple choice, they're not going to give you one like that where they both work because they're going to want one of those answers to be a distractor answer. So just read the question really carefully to pick out a clue about how you know if length is bigger or if width is bigger. Maybe they drew you a picture. In general, if they draw you a picture, don't assume it's to scale, but maybe they drew you a picture and said this is to scale and they already labeled that L was longer. Or maybe they came out and said L was longer. Okay? All right. Next. Still slide 24, number 3. There are 600 pupils in a school. The ratio of boys to girls in the school is 3 to 5. How many girls and how many boys? So what I would do, the ratio of boys to girls, I would let B stand for the number of boys and G stand for the number of girls. Ratio of boys to girls is 3 to 5. So there's my equation. And then I haven't used this idea that there are 600 pupils. So that would tell me that the boys plus the girls has to add up to be 600. Well, this is a really good, so again, a system of equations, two variables. The one where they are added is always very easy to solve and substitute for. Doesn't matter whether you pick boys or girls to solve for in this one. So if I just get B by itself, then B is 600 minus G. And then I'm going to take every time I see a B, and instead of writing B, I'm going to write 600 minus G. So 600 minus G over G. is equal to 3/5. I'm going to divide this out so you don't see that. Okay, this again is a situation where you could cross multiply because you have one fraction on the left equal to just one fraction on the right, but I'm going to show you the system of just clearing out clearing out fractions in your equations where you multiply by the least common denominator. Least common denominator here would be 5g. As long as I multiply by the same thing on both sides, I've kept it balanced, so that is okay. I'm going to use parentheses here, 5g times 600 minus g all over g. These g's that were multiplied and divided in front, not added and subtracted, those get to cancel. Then I'm not going to multiply the 3 and the 5 to get 15. I'm going to leave it as 3 times 5 times g over 5 because those 5's cancel. So yeah, I realize that you could do the math. 3 times 5 is 15, 15 over 5 is 3, but it's a lot simpler to just go ahead and cancel it out and not have to multiply. Keep in mind that the calculator you have access to is really basic, so the more math you can do in your head and be accurate, the better. And now I'm ready to distribute where I have my 5 times my 600, so I get 3,000 there. I'm going to write out the step for you that shows that just because it might help you. So I am working on 5 times 600 minus g is equal to 3g. And now I'm going to distribute the 5. So 5 times 600 gives me 3,000. Because 5 times 6 is 30, so that adds another 0. Minus 5g is equal to 3g. I'm going to add 5g to both sides so that my g's are positive and they're on the same side in just one step. So 3,000 is 8g, and so now I have to take 3,000 divided by 8. I get 375 equals g. Well, what was g? That was the number of girls. I always pick letters that, I try to always pick letters that go with what they stand for. So g was girls. So I have 375 girls. They want to know how many girls and how many boys. Well, so how many boys? The number of boys is 600 minus the number of girls. So boys equals 600 minus the 375 that I came up with for girls. So I end up with 225. So that means I have 375 girls and 225 boys. Okay, that wraps that one up. Still slide 24, number 4. This is again one that'll be nice with a pictorial representation. Perimeter of a rectangle, so all four sides, L, L, W, W is 280. So 2L plus 2W equals 280. The ratio of its length to width is 5 to 2. Length to width is 5 to 2. So there's my two equations with my two variables. Again, it's going to be easiest to substitute in the one that is added and subtracted. And again, just like the last time, the number that they're giving me there was even, so that means I can divide all the pieces by 2 and get L plus W equals 140. I just have smaller numbers to work with that way. Solve for either L or W. It does not make a difference. I've always been solving for the first one there, so maybe I'll switch it up on you and show you what it looks like to do the other. So W equals 140 minus L, and then I'm going to take that and I'm going to plug it into the second equation, that I had that also had L's and W's in it. So instead of L to W equals 5 to 2, I'm now going to have L to 140 minus L is equal to 5 to 2. Again, you can cross multiply. I'm going to show the strategy of just multiplying by the LCD on both sides because that works for any fraction equation. LCD here is 2 times the quantity 140 minus L. If you were going to get a common denominator for this, you'd have to incorporate both of those pieces. Okay, I'm not going to actually like distribute everything out, but I am going to distribute with the parentheses to get things cleaned up. Usually we'll put the single terms first, so 2 times L times the quantity 140 minus L, all over 140 minus L, those cancel, equals 5 times 2 times 140 minus L over 2. Those 2's cancel. So I'm left with 2L is equal to 5 times 140 minus L. Now I'm going to distribute on the right side. And so my 5 times 140 gives me 700. I'm going to keep my L's positive and solve this by just moving the L portion, not the L and the number, so add 5L to both sides. I get 7L equals 700. That's pretty nice. So L is equal to 100. And now we've got to go read the question to figure out what we need. The question wanted to know, find the area of the rectangle. So I need length times width. So I know the width is 140 minus L. So width is 140 minus 100, meaning it's 40. And then to actually answer the question was, what is the area? Well, area is length times width. So I'm going to take 100 times 40. So I'll end up with the 4 and then add up all the zeros, 0, 0, 0, 4,000. Okay. Units, did they give us units? Meters, so square meters. Alright, that wraps up that one. Still slide 24, number 5. The measure of two acute angles in a right triangle. I would again draw a picture. So I have my right triangle, and then I'm going to call this acute angle up at the top X, acute angle down at the bottom Y. So X to Y is in the ratio 2 to 7. Okay. What are the measures of the two angles? Well, right now I have two variables but only one equation. So I need to think through, how can I come up with another equation, but they're not telling me about area, they're not telling me about perimeter, but they did tell me this is a right triangle. So I know that this angle is 90 degrees. And I know that there are 180 degrees in a triangle. So 90 degrees plus x degrees plus y degrees is equal to 180 degrees. Because every triangle is made up of 180 degrees. Just like every circle is made up of 360 degrees, every line is made up of 180 degrees. Okay, so my two equations that I have to work with are, x over y is equal to 2 over 7. And my second equation is that 90 plus x plus y is equal to 180. I can subtract the 90, so x plus y would just be equal to 90. And as we've seen in the substitution elimination game, it's really easy to substitute using the equation where both were added. Pick to solve for x or y, it doesn't matter. So if I say x is 90 minus y, then I can take this part and substitute it over here every time I see an x. So equation 1 now becomes 90 minus y over y equals 2 over 7. And that's what I need to solve. So 90 minus y over y equals 2 over 7. Least common denominator there would be 7y. So the 7's cancel here and the y's cancel here. So 7 times 90 minus y is equal to 2y. Distributing your 90 times your 7, 9 and 7 is 63. So the fact that it's 90 instead of 9, 630 minus 7y is equal to 2y. Add 7y to both sides. So I get 9y, and 630 divided by 9 is 70. Okay, now I need to make sure I'm going to answer the question that they ask. So go up and read the question. What are the measures of the two acute angles? Because we already know the right angle is a 90. So I need to know x and I need to know y. We figured out what y is. It's 70 degrees. Remember, x was 90 minus y. So x is equal to 90 minus 70. So x is 20. So what are the two angles? That would be 20 degrees and 70 degrees. Okay, and then skipping to slide 30, there was one more word problem that the SI leader didn't ask me to go over, but I figured since you all were asking for some more word problem clarification, I would just do all the word problems that I saw. So this one is similar to that 50p, 25p, and 20p ratio question that we did in the first video. Mother distributed the money among Ron, Sam, and Maria in the ratio 2 to 3 to 5. So that's where you have some random quantity. I did the open box. I'm going to define R to be Ron's money and S to be Sam's money. Again, I pick letters that go with what they stand for. So M will be Maria's money. And then this box is just this random quantity that I start with so that I know how to multiply. So then the ratio of 2 to 3 to 5, I know that for Ron, that's going to be 2 times the box. And then for Sam, it's going to be 3 times the box. And for Maria, 5 times the box. Last time I left it with the box to show you a different way of doing it. You might have better success if you want to pick a variable for the box. Our last one we had already used x, y, and z, so you would have had to pick something else. But I have not used y or z. So you could say x is this box, and then you would have 2x, 3x, and 5x. Then we have not used this dollar amount that you get $150. Well, these were already dollars. Unlike in the first video where it was the number of coins and then I had to multiply by the value for the coin, for each coin, to get the overall money. I don't have to do that here because this stands for the money already and it's not being multiplied. So I know that Maria got and $50. Make sure you're really clear there that the 150 is not the total. 150 is what Maria got. So I can take that and solve the equation that 150 is equal to 5x. So then I can just divide by 5 on both sides, and I end up with 30 is equal to x, or is equal to the open box, however you want to do that. So now I know that random unknown quantity. This one, make sure you go back and read what they want to know. Find the total amount. So that would be adding up Ron and Sam and Maria's money. And then find the money received by Ron and Sam. So separate question. Okay, well, I already know how much Maria got. She got 150. And now I know this random quantity that it is 30. So if I take that, then this becomes equal to 2 times 30, which is 60. And then my next one is 3 times 30, so I get 90. And then they gave me that Maria got 150. So for my total, let me see what color I had used for that. For my total amount, I have 60 plus 90 plus 150. So I get 300. So total amount is $300. And then they wanted to know how much Ron and Sam got. Well, I figured that out. $60 for Ron and $90 for Sam. I could see them doing a question that wanted just the total of Ron and Sam, and that being all they asked for. Or maybe just picking one person and asking you to find how much that one person made. Okay, hopefully going through this, you've started to see a lot of patterns, at least in how I set these up, and that may or may not help you. If you'd like me to go over anything else, please email. I'm happy to do that. Just give me a problem that you would like worked out. But I find a lot of success with going the algebra route. A lot of you, most of us, have had a lot of practice solving algebra equations, and so if you can get an equation out of a word problem, rather than just trying to find the pattern to like scale things, I find it easier. Hopefully that helps you. Good luck. Let me know if you need anything.